Hello. So for our next topic, we will be discussing about creation and deployment of a sample application. So for this chapter, we will be discussing the Dockers, continuous improvement, continuous development, and then securing the data. So let's start. So first is the Dockers. So Docker is a way of creating and running a container. A container is a way of encapsulating everything you need to run your application so that it can easily be deployed in a variety of environments. So specifically, Docker is a format that wraps a number of different technologies to create what we know today as containers. Okay, so these are the technologies that are wrapped by Dockers. The first one is namespace. So these isolate different parts of a running container. Then we also have control groups, which are standard Linux concept that enables the system to limit the resource such as RAM or storage used by an application. And finally, we have union file systems, which are file systems that are built layer by layer, combining resources. Okay, so a Docker image is a set of read-only files which has no state. So it contains source code, libraries, and other dependencies needed to run an application. So it utilizes Docker container as its runtime instance. So you can have many running containers of the same Docker image. A Docker image is like a recipe for a cake, and you can make as many cakes considered as the Docker containers as you wish. So images can in turn be stored in registries such as Docker Hub, and overall the system looks like this, right? So creating a container involves pulling an image from a repository, then using it to create a container. So a simplified version of a workflow creating container looks like this. So first, either create a new image using Docker build or pull a copy of existing image from a registry using Docker pull, right? So it's this part. So depending on the circumstances, this step is like optional, right? So next is run a container based on image using a Docker run or Docker container create, right? Right. So the Docker daemon checks to see if it has a local copy, okay, of the image. If it does not, it pulls the image of um, from the registry. The Docker daemon creates a container based on the image, and if Docker run was used, logs onto it and executes the request command. So as you can see, if you're going to create a container-based deployment of a sample application, you're going to have to create an image. To do that, you need a Docker file. So let's discuss Docker file. Docker file is a utility file that is used to compile and build all pieces of the application. So it is a simple text file that defines the steps that Docker build command needs to create an image that can be used to create the target container. So here is the anatomy of a Docker file. So if all you could do with a Docker file is to create a clean operating system that would be useful. But what you need is a way to start with a template and build from there. So the complete list is available in the Docker documentation in the Docker file reference. So, but some of the available commands are here, right? So we have from, which initializes a new build stage and sets the base image from subsequent instructions. So as such, a valid Docker file must start with a from instruction. So we always start with from. And then maintainer, it sets the author field of the generated images. Run, it executes any commands in a new layer on top of the current image and commits the results. CMD provides defaults for an executing container. So these defaults can include an executable or they can omit the executable, in which case you must specify an entry point instruction as well. Expose, it informs Docker that the container listens on the specified network ports at runtime. You have env or environment. It sets the environment variable key to the value. Copy copies new files or directories from source and then adds them to the file system of the container at the path destination. Entry point allows you to configure a container that will run as an executable. Volume creates a mount point with the specific name and marks it as holding externally mounted volumes from native hosts or other containers. User creates a mount point with the specified name and marks it as holding externally mounted volumes from native host or other containers. Work directory or work dir sets the working directory for any run command, entry point, copy, and add instructions that follow in the Docker file. Arc defines a variable that users can pass at build time to the builder with a Docker build using command build argument var name is equal to value flag. Right. So on build adds to the image a trigger instruction to be executed at a later time when the image is used as the base for another field. Stop signal sets the system call sign that will be sent to the container to exit. And then label adds metadata to the image. So let's put some of these into an example. Right. So here is an example of a Docker file that containerizes a Python application. Right. So from Python working directory home Ubuntu, a copy and then run command and then expose. What does it mean? So from command installs Python in the Docker image. It invokes a Debian Linux-based default image from Docker Hub with the latest version of Python installed. The workdir command tells Docker to use home Ubuntu as the working directory. Copy command tells Docker to copy the sample app.py, right? File from Docker files current directory into home Ubuntu. And then run command allows you to directly run commands on the container. So in this example, Flask is installed. Flask is a platform to support your app as a web app. The cmd command will start the server when you run the actual container. Here you use the Python command to run the sample app.py inside the container. The expose command tells the Docker that you want to expose port 8080. So note that this is the port on which Flask is listening. So if you have configured your web server to listen somewhere else, such as HTTPS request on port 443, this is the place to note it, right? So let's now refer to the second image. So use the Docker build command to build the image. So in the following output, so this is actually the output. The image was previously built. Therefore, the Docker takes advantage of what is stored in cache to speed up the process. So as you can see, Docker goes through each step in the Docker file, right? Starting with a base image Python. So if this image doesn't exist in your system, Docker pulls it from the registry. So the default registry is Docker Hub. However, in a secure environment, you might set up your own registry of trusted container images. So notice that the image is actually a number of different images layered on top of each other. So just as you are layering your own command on top of the base image. So notice that between steps such as executing a command, Docker actually creates a new container and builds an intermediate image, so a new layer by saving that container. In fact, you can do that yourself by creating a container, making the changes you want, then saving the container as a new image. All right, so for the next one, so as you may recall, there are four different environments in a typical workflow, right? So we have the development environment, testing, staging, and production, which was discussed in the previous video. Sorry about that. Right. So we start by creating the development environment. So the development environment is meant to be convenient to the developer. It only needs to match the production environment where it is relevant. So for example, if the developer is working on functionality that has nothing to do with the database, the development environment does not need a replica of the production database or any database at all. So let me introduce to you continuous integration, continuous development, or CI/CD. So it is a philosophy for a software development that figures prominently in the field of DevOps or development operations, right? So DevOps itself is about communication and making certain that all members of the team are working together to ensure smooth operation. So let's break it down one by one. So for continuous integration, it is intended to eliminate problems wherein merge conflicts happen during the merging of a certain application back to the main application. So the idea behind continuous integration is that all other developers in the project continually merge your changes with the main environment of the existing application. This means that any given change set is small and the potential for problems is low. So if everyone is using the main branch, anyone who checks out code is going to have the latest version of what everyone else is developing. So as part of this process, developers are expected to perform extensive and usually automated testing, right, on their code before merging back into the main branch. So doing this, the idea is that most issues are caught before they become a serious problem. So this is what's involved in continuous integration. So write the code and then commit directly to the repository, and then an automatic test script is run after the commit, and then if there are errors, it goes back to the developers. If there's none, it after it has been committed to the repository, if there are no build issues, if there are build issues, it goes back to the developers. But if there are no build errors, it goes to the automated tests, right? So if the tests are sorry so if the tests fail, right, so it goes back to the developers and then they do it from start again. But if there's none, it goes to the next part, right? So the next no integration continuous integrations process provides a number of additional benefits, as every commit provides an opportunity for the system to perform additional tasks. So for example, the pipeline might be set to perform these tasks, right? Code compilation, unit test execution, static code analysis, integration testing, packaging and versioning, publishing the version, package to Docker Hub or other package repositories. So note that there are some situations that involve large and complicated changes, such as addition of new features, in which changes must be grouped together. So in this case, every commit may trigger only part of the CI or continuous integration pipeline, with the packaging and versioning steps running only when the entire feature is merged to the master, right? So in some cases, adjusting to its way of working requires change in thinking on the part of organization. So on the part of individual developers who may be used to working on their own branch or feature branches, these change is necessary, however, necessary. So if you're going to achieve the next step, which is continuous delivery, which is not quite the same as continuous deployment. So let's discuss on that. Right. Okay. So for continuous delivery, it is a process of developing in sprints that are short enough so that the code is always on, yeah, in a deployable state. So with continuous integration, small change sets are continuously integrated into the main code branch rather. Uh, CD means that those changes are engineered to be self-contained to the point where at any given time you could deploy a working application. So it's this part, right? So the process looks something like this. So to start, it starts with the version artifact that was created as part of the CI process, right? So it automatically deploys the candidate version on staging, right? So it is deployed to staging, and then integration tests are conducted. Integration, security, performance, scale tests, or other tests identified by the team or the organization. So these are known as gating tests because they determine whether this version of the software can be promoted further in the deployment process. So if all gating tests pass, tag this build as suitable for deployment. So it's deployed, right? So we have to note that CD does not mean you deploy constantly. The that process is called continuous deployment. Continuous delivery ensures that you always have a version that you can deploy, right? So you can also see here that if there are failed tests, the whole code goes back to the developers. So it goes back to CI once again, right? And then finally, for continuous deployment, it is the ultimate expression of CI/CD. So when changes are made, tested, integrated with the main branch, and tested again, they are deployed to production using automation. This means that the code is being deployed to production constantly, which means your user are going to be your final testers. So in other words, continuous deployment is a special type of continuous delivery in which every build that is marked as ready for production gets deployed. So some organizations favor this type of deployment because it means that users always have the most up-to-date code. Most organizations take more cautious approach that requires a human to push the code to production. Right. So in preventing impact to users, we have these three. So rolling upgrade. So this is the most straightforward version of continuous delivery. in which changes are periodically rolled out in such a way that they do not impact current users, and nobody should have to reinstall the software, right? Rollback lang. Canary pipeline. So in this case, the new version is rolled out to a subset of users or servers, depending on the architecture. If these users experience problems, the changes can easily be rolled back. If these users do not experience problems, the changes are rolled out to the rest of the production. And then finally, blue-green deployment. So it is an entirely new environment. So it's called blue. So it is created with a new code on it, but the old environment or the green is held in reserve. So if users on the new environment experiences problems, traffics can be diverted back to the original environment or the green. So if there are no problems with a specific amount of time, the new environment becomes the production environment and the old one is retired to be used for the next change. Right? So that's it for CD, right? So what are the benefits of implementing a CI/CD? So companies are willing to make such seemingly drastic change in their processes because of the benefits that come with using CI/CD for development. So these benefits include first, integration with agile methodologies. Agile development is built around the idea of short sprints after which the developer team delivers a functional application with some subset of the required features. CI/CD works within that same short sprint framework. Every commit is a version of the deliver a working version of a software concept. We also have shorter MTTR or mean time to resolution. So because change sets are small, it becomes much easier to isolate faults when they do occur and to either fix them or roll them back and resolve any issues. Right. So automated deployment. So with automated testing and predictable deployment comes the ability to do automated deployments. This means that it is possible to use deployment strategies such as canary release, pipeline deployment, in which one of the users gets the new feature set and the rest gets old. This process enables you to get live testing of the new feature to ensure it is functioning as expected before rolling it out to the entire user base. Right? For less disruptive user release, with development proceeding in small chunks that always result in a deployable artifact, it is possible to present users with incremental changes rather than large-scale changes that can be disorienting to users. And then we also have improved quality. All of these benefits add up to a higher quality software because it has been thoroughly tested before wide scale adoption. And because error resolution is easier, it is more likely to be handled in a timely manner rather than accruing technical debt. And then finally, we have improved time to market. So before features can be rolled out individually, they can be offered to users such as users much more quickly, yeah, quickly, than if they had to be deployed all at the same time, right? So that's all for CI/CD, and then the last topic that for these um, mm, no, not chapter. For these chapter, we have securing the data, right? So in securing data, we have these subtopics. We have encrypting or encryption, software vulnerabilities, storing too much data, storing data in the cloud, roaming devices, and best practices for transporting data. Okay, in securing the data, there are a lot of like things that we could consider, but it really is common to all because there are different types of data, right? And also different types of um, protection for a specific data. But for this report, I'll be discussing for these securities, and will probably add more based on how I experience in the previous projects that I was involved, right? So the first one is encryption or encrypting the data. So you have probably seen plenty of news stories about data breaches. So these are typically a matter of individuals accessing data that is stored but not protected. So in this context, this means that the data is stored in such a way that not only can an individual gain access, but that when they do, the data is readily visible and usable. So ideally, unauthorized person or application will never gain access to your systems, but obviously you cannot guarantee that. So when a person with bad intentions could just as easily as disgruntled employee who has legitimate access gets access to your database, you do not want them to see uh, something like this. So in this picture, right? So instead, you want to see them more like this. So you see, it's a database, but the data in the database is encrypted. There are two methods for encrypting data. So one is one way and another is two way. Right. So in terms of encryption of data, we have two. Um, you encrypt yeah, for example, let's say you have user Bob, right? Yeah, but that's for one way. So for two way, you encrypt the data using a key, and then you can use the key or a variation on it to decrypt the data to get it back to the plain text. And then we have one way. So in this case, you're not using any keys. So we create an encrypted value without necessarily using a specific key, but you cannot unencrypt it. So you would use that for the information you do need. You do not need to retrieve, just to need to compare such as passwords. So for example, let's say you have a user Bob who has a password Munich. So you could store the data as ganito, user and then scrambled password. So in this case, scrambling Munich, so Municch gives you this value, but there is no way to get it back from this one, right? So to check Bob's password when he logs back in, the logic usually searches for a record where the username is Bob and the scrambled password is this one. So after we should get the records given that the scrambled password you have provided is correct. Of course, the question then becomes if you're going to encrypt your data using a key, where do you store the key safely? You have a number of different options. So from specialized hardware, it is good but difficult and expensive, to using a key management service such as Amazon Key Management Services. So it uses specialty hardware, but is easier and less expensive. To storing it in database itself, which is not best practice, but has no specialty hardware or physical characteristics and is vulnerable to attacks. Right. So for the next one, we have software vulnerabilities. So security isn't the best suite for most developers. So codes should have code security vulnerabilities in the application, right? So when it comes to software vulnerabilities, you need to worry about two different types, your own and everyone else's. So most developers are not experts in security, so it is not uncommon to inadvertently code security vulnerabilities into your applications. So for this reason, there are a number of different code scanning tools that that will scan your code for well-known issues. These issues may be embedded in code you have written yourself, or they may be involved or they may involve the use of other libraries. So these other libraries are how you end up with everyone else's vulnerabilities. So even the software that has been in use for decades may have issues, right? Such as the heartbleed bug discovered in OpenSSL, the software that forms the basis of such of the internet. So the software has been around since 1998, but the bug was introduced in 2012 and sat undetected for 2 years before it was found and patched. So make sure that someone in your organization is responsible for keeping up with the latest vulnerabilities and patching them as appropriate. Right. So next one is storing too much data. Hackers do not get what you do not store and never store any data unless essential. So remember that hackers cannot get what you do not store, right? So for example, if you only need the credit card authorization code for recurring billing, there is no reason to store the entire credit card number. So this is particularly important when it comes to personally identifying information such as social security numbers and birthdays and other information that could be considered private, such as user's history, right? So unless you need the data for an essential function, do not store it. Right. So next is storing data in the cloud. So remember when you store the data in the cloud, you are by definition storing it someone else's computer. So while in many cases the cloud vendor security may be better than that of most enterprises, you still have the issue that those servers are completely outside of your control. You do not know which employees are accessing them or even that what happens to hard drives that are decommissioned. So this is particularly true when using SSDs as storage because the architectural structure of an SSD makes it difficult or impossible to truly wipe every sector. So make sure your data cloud is encrypted or otherwise protected. We also have roaming devices, which involves the loss of devices or the device encryption. So we have here a scenario in May of 2006. Right? The U.S. Department of Veterans Affairs lost a laptop that contained a database of personal information on 26.5 million veterans and service members. The laptop was eventually recovered. It's a good thing, but it's still a great example of why information must be stored in a secure way. So, particularly because the world's workforce is much more mobile now than it was in 2006. So in addition, apps are increasingly on devices that even more portable than laptops, such as tablets and especially mobile phone, right? So they are simply easier to lose. So these might not even be traditional apps such as databases, but apps targeted at the end user, right? So be sure you're not leaving your data vulnerable by encrypting it whenever possible. So I also have a scenario back in my previous company, right? I was using a device, personal device, of course, but it was encrypted by the company, right? So we have to install a certain software, and then it's encrypted, right? So one time I lost that device, and then what happened next was that I was per like um, operation. right? Whenever we lose different things that is connected or has any information, even slightly possible, right? The data of a certain client, we have to report it to a certain department so that that department could make any means necessary needed to wipe every data inside that device remotely. So in place, we have to make sure that we are able to really encrypt the device, not just the data, but the device. So when there is a need to wipe that down, when it was lost, right? Um, it is possible to really wipe out everything inside the device for data protection. Right. So the this is the last one, transporting data. So to prevent these problems, you could use these three, right? So data is also very vulnerable when it is being transmitted. So in fact, it may even be even more vulnerable because of the way the internet is designed. So where packets pass through multiple servers that may or may not belong to you on their way to their final destination. So this makes your data vulnerable to the man-in-the-middle attacks, in which a server along the way can observe, steal, and even change data as it goes by. So first is SSH. So when connecting to servers, always use a secure protocol such as SSH or secure shell rather than an insecure protocol such as Telnet, right? So SSH provides for authentication and encryption of messages between source and target machines, making it difficult or impossible to snoop on your actions. These days, all right, for the next one, right? So these days, the vast majority of requests to and from the internet uses HTTPS protocol rather than HTTP. So this protocol was originally called SSL or Secured Socket Layer, but over the years it has been gradually replaced with TLS or Transport Layer Security. So it provides message authentication and stronger ciphers than its predecessors. So whenever possible, you should be using TLS. Then lastly is the VPN. So a VPN makes it possible to keep all application related traffic inside your network, even when working with remote employees. So VPN or virtual private networks are perhaps the most important means for protecting your applications, right? The remote employee connects to a VPN server, which then acts as a proxy and encrypts all data to and from the user. So using a VPN has several benefits. First, traffic to and from the user is not vulnerable to snooping or manipulation, so nobody can use the connection to damage your application or network. Second, because the user is essentially inside the private network, you can restrict access to development and deployment resources, as well as resources that do not need to be accessible to end users, such as raw databases. So VPN is actually very handy, especially to us who are securing, accessing systems, right? And we are not inside the office, but since our work requires us to have a connection or have access to certain systems inside the client, we are using the VPN so that we have a secure connection and from the network. So I think that's all for uh, this chapter. So we've already finished creating and deploying a sample application. So in the next part, we will be discussing on SQL injection.